Welcome to GATE CSE ML. Today we'll see the concept of matrix factorizations. Before that, like what is the goal? What is that we are learning in linear algebra? Is about to reduce the number of entries in a matrix. Any given problem, you convert it into a matrix form so that it is easy to form, and then to make it less computationally intensive, you are converting that dense matrix. Dense matrix means most of the entries are non-zero, to sparse matrix where your most of the entries are 0, so that when I compute this, it becomes efficient. I don't use much resources. So you will learn different methods like diagonalization, eigenvectors, eigenvalues. Okay, so based on that, you can reduce some matrices. There is another technique called as matrix factorization. So matrix factorization means there are different techniques in this. One standard technique is LU decomposition. That's what we're going to learn. LU decomposition. So that means what? To convert a given matrix A in the form L into U. L is a lower triangular matrix, U is a upper triangular matrix. So that means what? The lower triangular matrix, all the upper part of a triangle is a matrix like this A. So if I convert this to this, they are 0, then it's a lower triangular matrix. If they are 1 or non-zero, then it is a upper triangular matrix. So convert that so that I will have less number of entries. That means more zeros are there in my matrix, so that it becomes a sparse matrix. So we'll see how to do it. Okay. Now, what is the use? I told already. Is this the, if it is a lower triangular, upper triangular matrix, then you can easily find the determinants, inverses, and all those things. So it simplifies your solving the linear systems. So now how to perform this? This is the standard definition of your LU decomposition. So given matrix is converted into two matrices, lower triangular and upper triangular. Okay, so lower triangular with unit diagonal and strictly upper triangular matrix. We'll see how to convert this. How it helps? It helps us to find the efficient solution for the system of linear equations. And the determinant is nothing but what? For a triangular matrices, it's a product of all the diagonal elements. So pi here means what? Product. UII means diagonal element, product of all diagonal elements. Then you can also find the inverse easily. So now we'll see a method to find the LU decomposition. How to perform LU decomposition? LU decomposition means what? This matrix A I have to convert into two different matrices. That is one lower triangular and another is the upper triangular matrix. So there are different methods again. Like you can use row echelon form. You can use Doolittle's method. There are different techniques. So we already learned row echelon form. So using that, I will convert this matrix into LU matrices. Okay. So let's begin. So try to understand this very simple concept. Just be careful and concentrate. So let us apply row echelon form. So this is my pivot element. So I want to make this entry below that pivot element 0. So how will I make it? I will make it as R2 is R2 minus. So to make it 0, I have to multiply it by 3 by 2 minus 3 by 2 R1. So the reduced matrix will be 4, 3, 0. Then this will be 3 minus 3 by 2. So 1.5. Now this, whatever you see it as 0 here. This is an upper triangular matrix. So I have got my upper triangular matrix. This is my U. Now the important point here is how will you find the L? It's also simple to observe here. The L, so I write 2 cross 2 matrix L. So I already said that L will have unit diagonal elements. Unit means 1 as the diagonal entries. So lower triangle will have 0 here. These entries will be 0 here, upper triangular part. So I have to find this. What is this element? Okay, what is this element? You have to find. So there we have some concept called as multiplier. multiplier. So what is this entry here? I second row, first column. This is what is that I have to find. What is the concept of multiplier? It is very simple. So whenever you write convert row echelon form, this part becomes important here. Okay, this part becomes important. This multiplier I to 1 in the main matrix. This is the initial matrix. This was the element, right? I made it 0. How did you make it 0? Okay, with using what multiplier you made it 0? If you observe here, I made this 6 0 by multiplying 3 by 2 to R1. So this is my multiplier. This is my multiplier. This is my multiplier 3 by 2. Now what is the standard form? What is that I have done here? R2 means Ri. Let us say a matrix Ri. I reduced it as Ri minus I of I j into R of some j. Okay, here it is I is 2 and j is 1 in this example. Now I can just return it as standard form as Ri. Let us say it as plus minus Ij into Rj. Okay, you not remember this now. So what will be the element here? Element here will be this I21. I21 is what? 3 by 2. 3 by 2 is 1.5. 3 by 2 is 1.5. Now, what is the sign of this? See, when I taken minus 3 by 2, I will just change this sign. It becomes plus. Okay, that means L is final is 1, 0, 1.5 and 1. Because the sign here is minus. Because I am converting to this form. Okay. If you want the formula base, you apply this. Or what you do is whatever is there here, minus 1.5, right? So write it as plus 1.5, only change the sign. So first you write minus 3 by 2 and then change the sign. So both are same. Or else you apply this formula and do it. So 1, 0 plus 1.5 and 1. This is my lower triangular matrix. So if I multiply this, I will get A. Okay, so only be careful about this sign. So only as it is in this form, okay. So what it is, if you solve by formula, I of ij multiplier, in my case equal to minus 3 by 2. That is what I am saying. So it becomes plus I of j is equal to 1.5. Or whatever value is there, including the sign, you write it here and then change the sign. Both means the same. Next. One more example, 3 cross 3 matrix. So the given matrix is 2, 1, 1, 4, minus 6, 0, minus 2, 7, 2. So first reduce these elements. The only thing is you just note down the multipliers for each row operations. So if I want to make this is the pivot element. If I want to make this 0, so R2 is R2 minus 2 R1. What is the important thing here? Important thing is here this minus 2, because for lower triangular matrix I will need this. Now continue solving this. 2, 1, 1, 0 become minus 8 and then 0 minus 2 minus 2. Okay. Next, this is 2, 7, 2. Now we will make this as 0. How will I write? R2, R3 is R3, so minus R1. Okay, 2 minus 2, so this is minus 2. So plus R1. So now what is here? I can write this as 1 R1, right? 1 R1. So this is one more multiplier I am getting it here. So please note this. Next, so what is the matrix I'll get? 2, 1, 1, 0, minus 8, minus 2, then 0, 8, 3. Still it is in not in triangular form. So I have to make this 0, this element 0. This minus 8 is the pivot element. Make element below it as 0. So how will you make? Next, R3 is, if I add this 2 rows, it becomes 0. So R3 plus is again 1 R2. So again you note down this 1. Okay. Minus 2 plus 1 plus 1. Now what will be this resultant matrix? So this will be 2, 1, 1, 0, minus 8, minus 2, 0, 0, then 1. So this is now in upper triangular form. This is my U. Now how will you find your L? L is 3 cross 3 matrix. So make all diagonals 1 and then rest of the entries 0 in the upper triangular part. Now you have to find these elements. So what is that multiplier? I, this is second row, first column. I21 is equal to what? I have to find I31 equal to, and then I have to find I32. Okay. This and this. Okay. How will I find? How did I reduce this element to 0? How did I make 4 0? Using this. So minus 2. So when you write here, make it plus 2. Only change the sign. So it becomes 2. How did I make this entry 0? It is minus 2 0. I made this minus 2 0 using what? This operation, right? I added this. So this element becomes 0. What I added? 1 R1. So 1 is the multiplier. So plus 1. So minus 1. Change the sign. Then similarly here, how did I make this element 0? Okay, this element 0. I added this element to this. What is it? I added 1 R1, 1 R2. So plus 1 was there. Multiplier is plus 1. So make it minus 1. So if you calculate using our standard formula also, we'll get it as 2 minus 1 minus 1. This is my four triangular matrix. If you multiply LU, you get my A. Okay, this is how you have to solve. Now, there is a problem here. So, even in row echelon form, if the pivot element is 0, okay, if the first element, for example here, if instead of 2, it was 0 here, then how will you find? It will become difficult to find the row echelon form. So that is called as no pivoting. We assume all pivots entries are non-zero. Works for many cases but may fail. Pivot is 0 or very small. Okay. So for that there are two solutions. One is partial pivoting and another is full pivoting. Partial pivoting, swap rows during elimination so that largest available pivot element is chosen. So it improves numerical stability. Full pivoting means swap both rows and columns for the best pivot choice. This is not followed in practice in common. I will see an example for it. If the matrix is given like this, the pivot element is very small or it may be 0. Now what will happen if this is 0? When I calculate that multiplier in my LU decomposition, this becomes very big number. That is what I am doing is to make this element as 0. If this is my pivot element, what is that I have to do? R2 is R2 minus 10,000 R1. Now this is becomes my multiplier, right, for this I21. So that leads to inconsistent results or instability. Okay, this leads to incorrect solutions. For that, what you have to do, you go for full pivoting or partial pivoting. Partial pivoting means, so you swap these rows. So this make this as 1. The second row as the pivot element, this first element of the second row. Swap these two rows. So swap to these two rows, then it become 1. Now my becomes safe to eliminate this element. Okay, it becomes safe to eliminate this element. If it was 0, then good enough. Already I will have a triangular matrix. This is how you do partial pivoting. Okay, hope you understood. It's a very simple concept and more very widely used concept in linear algebra. Now we'll apply LU decomposition to solve system of linear equations. So how to find? So what is that you're finding? Ax is equal to b. So I'm finding x. So now this ax, you are split it as LU. LU x equal to b. So how will you find? So using forward substitution and backward substitution. What it means? First you solve Ly equal to b. Then you will get y vector, that is say y1, y2, y3. This is called as forward substitution. Then you solve ux equal to y. You will get x, x1, x2, x3. This is called as backward substitution. Okay. So forward substitution means Ly equal to b, and backward substitution means ux equal to y. So let's see an example. Same example previously I have seen. So the equations are given like this system of linear equations. So instead of x, y, z, I am using x1, x2, x3. So you find the coefficient matrix. This is the coefficient matrix. Then you can decompose it to LU. So for the same example, you got L and U in the previous example. So this is my LU. Then you perform forward substitution and backward substitution. So let us see. What is my L? L is 100210. The last row is -1, -1, 1 into y. So there are three variables. I will take y vector as y1, y2, y3. This should be equal to b. What is my b? 5 minus 2, 9. Okay. Now, so you find the solution. So y1 will be 5. Then 2y1 plus y2 is equal to -2. So y2 will be equal to -2 minus 10, that is -12. Then the last equation is minus y1 minus y2 plus y3 equal to 9. So y3 will be 9 plus y1 plus y2. It is 9. y1 is plus 5. y2 is -12. This is 2. So you found out our y vector, that is y1, y2, y3 is 5 -12 and then 2. Next you find the x using backward substitution. The backward substitution ux. What is my u? 2, 1, 1, 0, -8, -2 and 0, 0, 1 into my x vector x1, x2, x3. This is equal to y. So y we have already found out using forward substitution. Now apply backward substitution. Now, so I'll get x3 equal to 2 from this. Then -8 x2 minus 2 x3 is equal to -12. So if I solve this, -8 x2 is equal to -12 plus 4. So x2 is equal to 1 and then x3 equal to 2. To find x1, so 2x1 plus x2 plus x3 is equal to 5. 2x1 equal to 5 minus x2 minus x3. This 5 minus x2 is 1 minus 2. 2x1 equal to 2, x1 equal to 1. So my x vector equal to 1, 1, 2. So this is the answer, solution. So this is how you can solve the system of linear equations using LU decomposition. We'll solve few more problems in the next video. Thanks for watching. We'll continue in the next video.